Hey guys, Mr. Wynn here. I want to talk to you about learning target number 3, which is about carbon. So I can describe the function, the structure, and the importance of carbon. So as you can see here, what I've stressed is that carbon makes 4 bonds. So it makes this bond here, 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 and here. And it is also covalent. So it's going to form covalent bonds as opposed to ionic bonds. Now if you remember, covalent bonds are bonds that form whenever elements share electrons. So they're going to share electrons with, let's say for instance, an element like hydrogen. So in this instance here, you can see that carbon is going to form bonds with all 4 of these hydrogens. And that's what makes carbon a covalent bond, and it forms 4 of these bonds. It's a very, very diverse and a very, very important compound, or important element because of that. Now, if we look further down, we have this idea that these compounds are made up of monomers, okay, and these monomers are going to be this single molecule. Now, the single molecule is going to join together with another monomer in order to make a polymer. Now, the monomer joins together, or these 2 monomers join together through a process called condensation reaction. So with this condensation reaction, these 2 monomers are being put together in order to form a polymer, and eventually this is going to grow even bigger to where we're going to have all sorts of different connections from monomer to monomer to monomer, and then it's going to go on and on and on to form a macromolecule. Okay, so in number 1, compound made up of repeated link units is called a polymer. Number 2, how many bonds and what types of bonds do carbon form? Carbon is 6 on the periodic table. Now, carbon is going to form 4 covalent bonds. Carbon forms straight, branched, and what other type of shape? Okay, so let's look at that. So you can see that these are the 3 different types of shapes that carbon can form. Now this one is just our straight hydrocarbon chain. So if we were to add hydrogen, this is what we would typically see with a lipid. This is a branched shape where the hydrogen is not going to form this straight shape, but instead it's going to spread out so that you're going to see some type of 3D dimensional curving, 3D dimensional shape occurring. And then we have this ringed shape. Now this ringed shape that you see is typically not going to show all these carbons. So with these different carbons, or with these different rings, these are the rings filled in with all the C's in it. So again, ringed, branched, and straight. Now, on question number 4, carbon 14 differs from carbon 12 because of the different number of neutrons. Now, carbon, again, is 6 on the periodic table. So if carbon is 6 on the periodic table, then that means that it's going to have 6 protons. Now, protons will never change. So a carbon 14 differs from carbon 12 not in the number of protons, because if it were to change in terms of protons, it wouldn't be carbon anymore. So protons give an element its identity. Okay, so again, what we're talking here is we're talking about carbon 14 versus carbon 12. And they're going to differ in terms of neutrons. Now, the order of how compounds are constructed is, okay, so compounds are always going to start with atoms. Okay, so we're going to have our atoms that form our monomer, that form our polymer, that form our macromolecule. Okay. On number 6, explain why the following are considered isomers. Now, of course, if you want to think back to what the definition of isomers are going to be compounds that had the same chemical formula. Okay, they have the same chemical formula, but they have different structure. So we have specific examples of monosaccharides. Okay, monosaccharides that have the same exact chemical formula, but they have different structure. So let's take a look at that. Now, if you recall, monosaccharides have this chemical formula. Now, C6H12O6 means that each one of these different isomers are going to have 6 carbon, 12 hydrogen, and 6 oxygen. Now, each one of these different monosaccharides are going to look a little bit different. So let's look at these two and let's try to figure out what the differences are. So again, these two monosaccharides have the same chemical formula, C6H12O6. The only difference between the two is that if you look at the shapes are completely different. So 1, 2, 3, 4, 5. This one has 5 sides as opposed to 1, 2, 3, 4, 5, and 6. Now, you can also see that the placement of the OHs are going to be different, or the hydroxide groups. So the hydroxide group is connected to this end of the carbon, whereas there's no end here that has the hydroxide group. And instead you have this CH2OH being connected to this side as opposed to anything that's on this side here. So the placement of CH2OH is going to be different in terms of both of these monosaccharides. So again, the reason why they're considered isomers is because they have the same chemical formula, which is C6H12O6, but they have different placement of the structures with CH2OH and OH and OH, okay? And also the shape, 1, 2, 3, 4, 5 versus 1, 2, 3, 4, 5, 6. Now, what are the 4 organic molecules? Okay, so the 4 organic molecules, if you ever want to think about an easy way to remember this, is to remember how do we differentiate our food. Okay, so we're always going to differentiate our food based off of 3 different categories. Now, our 3 different categories are going to be carbs, proteins, lipids, which are also called fats. Okay, so this is the 3 different ways in which we differentiate our food. So we always want to figure out whether or not we have if we have a food that's full of carbs, full of protein, or full of lipids or fats. Now, the last organic molecule that you'll have to remember is a nucleic acid. So nucleic acids have to do with DNA and RNA. Okay, so again, whenever I ask you for your 4 organic molecules, okay, one right here, 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 and here. All right, so if you have any questions about Learning Target 3, please don't hesitate to ask, and thank you so much for watching this video.